In this video, we're going to talk about resistors in series and parallel. That's combination or connection of resistors. The reason we combine resistors is to obtain the desired resistance. Now, we have two ways of combining them or connecting them, which is by series or by parallel. So when we connect them in series, or what we call serial connection, it means that they are, this is the symbol of a resistor. This is how they are connected. Or we have something like this. Provided there is no junction, they are in series. And when they are in series, more voltage is drawn. It means more resistance, lesser current is flowing. The more resistors you combine, lesser current will flow. It means if you apply a bulb, an example of a resistor is a light bulb, the bulb will appear dimmer because more resistance will be experienced. But when we have a parallel connection, in serial connection, we have that arrow total or equivalent is giving us arrow 1 plus arrow 2 down to how many R that you have. In parallel connection, they are this way. When you see a junction, then they are in parallel. Or another example, they are in parallel. When you see a junction, they are in parallel. And when they are in parallel, the arrow equivalent or arrow total is giving us, that's 1 over t equal to 1 over arrow 1 plus 1 over arrow 2 down to how many R that you have. So when you connect them in parallel, voltage is the same for all of them. It doesn't matter how many light bulbs. There will be less resistance, there will be increase in current. The only disadvantage is that more power will be drawn from the battery, that is the source. An example is determine the current flowing in each resistors and the equivalent resistance if three resistors 9 ohm, 2 ohm and 6 ohm are connected in series and a 120 volt battery is connected across the combinations. Now we can first of all have a little sketch. This is the symbol. They are in series and a battery of 120 volts is connected. So here is 9 ohm and here is 2 ohm and here is 6 ohm. Now for us, before we can calculate the current flowing, we must first of all calculate the equivalent resistance. And remember, since they are in series, we have that arrow equivalent is equal to arrow 1 plus arrow 2 plus arrow 3, which is 9 plus 2 plus 6. So 9 plus 2 and plus 6. So we'll have 17 ohm as the arrow equivalent. Now, for us to now calculate the current that is flowing, remember according to Ohm's law that V is equal to IR. This R is the arrow equivalent that we're going to use. So if we make I subject of the formula, I is equal to V over R. Therefore, V they give to us is 120 volts. So 120 over R that we got is 17. And if we divide that, we're going to have that the current flowing is equal to 0.706 ampere approximately. Sorry, is going to be 7 0.05, so let's say 7.1 ampere. I beg your pardon. 120 divided, I thought, well, it's 12 divided by 17. Just checked it again, so please correct that. Thank you. This question says, draw a circuit containing three resistances, R1, R2, and R3, connected in parallel with an EMF source. Also, show how an ammeter and a voltmeter can be connected to this circuit in order to measure current and potential difference. Now, since they are in parallel, the first thing we can do is to draw. We can use the box to show. Another way of showing resistor is also this format. So from here, they're in parallel now. And they said also show how an ammeter. So we have to show how an ammeter is connected. Okay, an ammeter and a voltmeter. A voltmeter will have to be connected in parallel to this circuit. Then this is the battery. This is the battery. So this is the voltmeter. So you need to know that an ammeter has very low resistance. So an ammeter has a very low resistance and is connected in series with this circuit. But a voltmeter has high resistance, so it's connected in parallel to the circuit. So the next question that we have is this circuit, for example. If we have, this is the first resistor, second, third, fourth, five. So we name this one R1, R2, R3, R4, and R5. If you look at it properly, you will notice that R1 and R2 are in series, straight line. So notice that R1, R2, they are in series. So because of that, we have 15 ohm plus 5 ohm, which will give you 20 ohm. So we call this series 1. So if we draw that, we're going to have something that looks like this. Sorry. We're going to have something like this, combining these two. So if you notice, sorry, let's make it more straightforward. Series 1 is going to look like this. This is how it's going to look. Made a mistake here. So this is what it will look like. So here remains R05. Here remains R03. Here remains R04. And here is now series 1. So if you check again, R03 and series 1 are in parallel. So R03 and series 1 are now in parallel. So what you see is 1 over, let's call it parallel 1, is equal to, if you check, this is 10 ohm, and here we've gotten 20 ohm. So what you're going to have is 1 over 20 plus 1 over 10. Their LCM is 20. 20 in here is going to be 1. 1 times is 1. 10 in here is 2. 2 times this, 2. So 3 over 20. So you're going to have that 1 over parallel 1 is 3 over 20. Therefore, parallel 1 is equal to 20 over 3. Okay, so arrow 4 and parallel 1 are now in series. And remember, arrow 4 from the question is 5 ohm. So for us to do that, let's call it series 2 because we solved the first series. So series 2 is now arrow 4 plus parallel 1. Arrow 4 is 5 ohm plus parallel 1, we got it to be 20 over 3. So if we resolve that, their LCM will be 3, that's over 1. 3, 1 into here, 3 times here is 15, 3 into here, 1 times 20 is 20. So we're going to have 35 over 3. So S2 or series 2 is 35 over 3. So ohm. So having gotten that, it will now look like this. This is how it will now look. This is our arrow 5. This is our series 2. And remember, series 2 we got 35 over 3. And here is 10 ohm. So what we're going to now have, they are now in parallel. So what we will now do is that total, which is 1 over ROT, is equal to, here we got 35 over, so 1 over 35 over 3 plus here is 10 with 1 over 10. We'll have, if we turn here upside down, we invert 3 over 35 plus 1 over 10. So the LCM is 350. That's this times this, 350. So here into here you get 10. 10 times 3 is 30 plus here into here you get 35. 35 times 1 is 35. So right, so we'll have 65 over 350, which if we reduce it we'll get 13 over 70. Yeah, therefore if we have ROT alone will now be, we invert. If we invert we'll have 70 over 13. 70 over 13, which will give us 5.38 ohm. Thank you.